Hello students, today we will discuss about the third application of Gauss theorem, that is electric field intensity at a point due to infinite plane charge sheet. It means here the size of sheet is not defined. Suppose we have a charge sheet which is positively charged having surface charge density sigma. Sigma means the amount of charge that present in per unit area. So suppose if this one is a sheet, infinitely plane sheet, it is kept like this. So in both the side, electric lines of forces will emerge in leftward as well as rightward, and we have to find electric field intensity at point P, which is at distance r. For this purpose, we assume another point P dash, which is just opposite to P and equidistant as P. So these are the electric lines of forces that emerged out from the sheet. Now we take a very small segment of the sheet whose area is A. So the electric lines of forces which emerge out from this area. So if we join all those points which is present at distance r from both sides, along both sides of the sheet, then we get a cylindrical Gaussian surface. It is cylindrical Gaussian surface of area cross section capital A. Its area cross section is capital A. So see here, this is the direction of area cross section of the cylindrical surface, and this is the direction of curved surface. Curved surface on both sides. It is the direction of curved surface. So see here, for curved surface, electric field, direction of electric field and the direction of curved surface are perpendicular. So no any flux linked with its curved surface. Only flux is linked with its area cross section. So flux linked with its left end area cross section. Suppose it is phi 1 is equal to E A cos 0, that is E A. Why cos 0? Because E and A both are parallel. At both end, both are parallel. So here flux linked at second end, it is phi 2. Suppose it is also E A cos 0 is equal to E. And flux linked with the curved surface, it is equal to 0, because curved surface and electric field both are perpendicular. So what is the total flux linked with whole cylindrical Gaussian surface? It is phi E is equal to EA plus EA, that is 2EA. This is the total flux linked with whole cylindrical Gaussian surface. And by Gauss theorem, as we know that phi E is equal to Q by epsilon 0. So what is the amount of charge that linked with this Gaussian surface of area cross section A? It is A. So it is equal to, suppose Q dash, here written Q dash is equal to surface charge density into area, to Q dash by epsilon 0. It is equal to 2E. So electric field intensity E is equal to Q dash by 2 epsilon 0 E. It is in terms of charge, but since charge Q dash that linked with the Gaussian surface is equal to surface charge density sigma into A. Sigma is the surface charge density of this whole sheet. Correct? So amount of charge that present in this cylindrical Gaussian surface, it is Q dash. So instead of Q dash, write down sigma A. So E is equal to sigma A by 2 epsilon 0 A. A and A get cancelled. E is equal to sigma by 2 epsilon 0. Means electric field intensity is depend on surface charge density. If surface charge density of the given sheet is more, then electric field intensity at a given point that will be more. So it is very important, and it is asked in your annual exam also. Now The application of electric field intensity due to infinite plane sheet. This is second case you can say, or you can say applications. So let's see. If we have two plane sheets and they are kept parallel to each other, so what is the electric field intensity at different regions? Here we have two plane sheets. They are kept parallel to each other, having surface charge density sigma, suppose it is A, and sigma B. Alright, sigma 1 and sigma 2, which is better. Sigma 1 and sigma 2. So whole space divided into three regions. This board is divided into three regions. It is first region, it is second region, and this one is third region. Clear? Supposing first region, it lies along x negative axis, it is x positive axis, and it is in between them. So first region lies left of first sheet as well as left of second sheet. So suppose E1 is the electric field intensity which is produced by first sheet, and E second is the electric field intensity that produced by second sheet. In second region lies right of first and left of second. So this is the direction of electric field that produced by first sheet, and this is the direction of electric field that produced by second sheet. Third region lies right of second as well as right of first. So this is the direction of electric field that produced by first, and this is the direction of electric field that produced by second. Clear? So see in first region. In first region, E1, electric field intensity produced by first sheet is equal to sigma first by 2 epsilon 0. Sigma first by 2, correct? Produced by second sheet, E second is equal to sigma second by 2 epsilon 0. See here, since first region present left of both the sheet, or you can say x negative axis of both the sheets, so both are negative. Therefore, net EFI in first region become minus 1 upon 2 epsilon 0 sigma first plus sigma second. This is the net EFI in first region. Now in second region, electric field intensity produced by first sheet. For first sheet, it is second region present along x positive axis, right of first sheet. So it is sigma first by 2 epsilon 0, and by second sheet, it see here second region present left of second sheet means along x negative axis. So it is minus sigma second by 2 epsilon 0. Therefore, net EFI in second region, it is equal to 1 upon 2 epsilon 0 sigma first minus sigma second. Similarly, in third region, This third region present right of first seat as well as second seat, or you can say along x positive axis for both the seats. So EFI due to first seat in third region, it is equal to sigma first by 2 epsilon 0, and due to second seat it is sigma second by 2 epsilon 0. Therefore, net EFI in third region, it is 1 upon 2 epsilon 0 taken as common, sigma first plus sigma second. It is EFI in third region. Clear? For first region, for second region, and for third region. You may take different cases. Suppose if sigma first is equal to sigma second, you may get a different result in all the three regions. Case second, if both are negatively charged, to minus sigma first and minus sigma second. If both are negatively charged but equal, it means if minus sigma first is equal to minus sigma second is equal to suppose minus sigma, then you will get three different results. If one is positive and other is negative, suppose case fourth, if sigma first is equal to plus sigma first and sigma second is equal to minus sigma second, so you will get another result. Case fifth, if first one is negatively charged minus sigma first and second is positively, that is plus sigma second, so you will get the different result for all the three regions. Electric field intensity at a point due to two infinitely parallel plane sheet. Thank you.